So we've spent some time looking at how to graph an inequality. So graph the solutions of something like x is greater than or equal to 5, and we know how to do that. It's now time to take the next step and look at solving inequalities, ones that aren't in this format where we can see the solution real easily. Something that looks along the lines like 2x plus 1 is greater than or equal to 11. It's in a form where we have to do some mathematics in order to get it to look more like the above situation. And notice this looks very, very similar to equations that we've been working with in algebra all year long, something like 2x plus 1 equals 11. And just like in this case over here where we have to solve the equation to find out what x is equal to, over here we'll do the same mathematics in order to find out where all the solutions for this inequality lie. So, like over here, we need to undo the operations of adding 1 and multiplying by 2 to isolate this x. We'll want to do the same things over here. We want to isolate this x by undoing the operations of addition and multiplication. Well, to work backwards from our order of operations, we need to undo this adding by 1 first. And to undo adding by 1, we're going to subtract 1. And just like in this equation over here, whatever we do to one side of this inequality, we have to do to the other. So I subtracted 1 from the left, I'm going to subtract 1 from the right, and I get 2x is still greater than or equal to 10. Now I need to worry about undoing the operation of multiplication. The inverse operation of multiplication is division. So I'm going to divide the left side by 2. Whatever I do to one side of this inequality, I do to the other. I divide the other side by 2, and I get a statement that says x is greater than or equal to 5, which is an abstract idea of what my solution looks like. We always want to show visually or concretely what that might look like. So I'm going to draw my number line. I'm going to put arrows on both sides of it because I want to show that this thing extends both directions. And I identify my 0, 1, 2, 3, 4, 5. It's always nice to show some of the negative side of the number line. This says x is greater than or equal to 5, so I know it includes the value of 5, so I'm going to use a closed dot, and all the numbers that are greater than or equal to 5 exist this direction on the number line.